Okay, sorry if you have to use one of these. They're not as good as the others, but they still work. And I gave out all the other ones, so this is what I'm going to use. Okay. So very quickly, it says... It starts with a construction thing, okay? So it says, draw a right angled triangle with an angle of 35 degrees. Okay, you right? So here's where you begin. Just take one of these, Kyle. No, you can sit down. You can sit down because you should have come 5 minutes ago when everyone else came. Now we're going to start. Shh. So you should have a straight edge of some kind, either one part of your protractor or a ruler of whatever. Start by drawing a line, any line. It's all fine.
So can I please have a sheet?
You can. Oh, you can stick one too.
No, thanks.
Okay. Now we want a right angle because it's a right angled triangle, right? So off of this line, I'm going to draw up a right angle like this. Okay. So if you want, alternatively, you can get at your protractor and you can put the central point of the protractor there, and then 90 degrees will be straight up. Okay. But 90 degrees, we're pretty good at visualizing right angles, so you may be able to just sort of slap this up, and you'll get a line like so. Okay. Now, I don't know how far this is going to be. Okay. So I've kind of drawn them of, I don't know what length they are, and it kind of doesn't matter. Okay. Now you reach for your protractor. Okay. Now, if you've drawn yours the same orientation as mine, kind of like a letter L. Okay. Where I would put the point of the protractor is down on the end here. Okay. Down on the end here. So when you place it there, you want to read up. Okay. And so I'm going to draw a bit bigger because it's too small for you to visualize. So you've got your 90 degrees up here, and that means 45 will be somewhere over here. Okay. What do we want? 35 degrees, right?
35.
35. Okay. So I'm guessing 35 will be somewhere around here. Okay. So our line looks like this. This will have to do. Sorry. Okay. So you placed the center point on the end of that line. Okay. So you want to read up to 35. Right? So this is the angle we're going to draw in a second. Okay? So with your protractor there, I would put a point there, like so, and then you can take your protractor away. Okay, now I'm going to try and do it here. It's going to be really small, but it should still work. Okay. Now having placed that point on there, now you're just going to join the end here, up to here, until it meets that other vertical line that we drew. Okay, so it looks something like this, I guess. I'm going to be... Yeah, I'll just reach. Well, I lost it a bit at the end. It's hard to hold a ruler that's longer than your arm, but anyway, there you go, okay? So number one, it's right angle, because that's what we started with. And number two, we used the protractor, and we've got this 35-degree angle there, okay? Then it says measure the length of each side. Now remember, we just sort of drew lines and we didn't measure it at all. So I assume everyone's got a different size triangle, like between each other and to me, but it doesn't matter. The whole point of the trigonometric ratios is that what we're going to get will be the same whatever the lengths of these are. Okay, so you get out your ruler, I'm going to measure mine, and measure out the sides. Which sides do they want? All of them. Okay, so let's measure them. Okay. So here's what I've measured. I got kind of lucky actually. If I'd made it any bigger, because this is only a meter long, so good thing I managed to fit mine in. You'll have some different measurements, okay? I want you to put yours in as well, and let's continue on. It says, use the length measurements to calculate, and then it gives us these three ratios, okay? Sine, cos, and tan, all of the angle, 35 degrees. Like so, okay? Use the length measurements to calculate them. So where we started was to say, well, sine is just opposite on hypotenuse, right? Are you guys warm enough? Can I turn this off yet? Yes. Hands up, leave it on. Oh, that's okay, fine. Sorry, people who are home. You just have to.
I'll go outside.
I'll turn off in 5 minutes, okay?
Oh.
So, sorry, where were we? We used our mnemonic device like so to remember which ratios match up to which sides, okay? So, let's write it off. Here we go. Sine is opposite on hypotenuse. So on my triangle, right, I've got opposite on hypotenuse. Maybe we'll just mark them in quickly. You've got the opposite side over here. Here's the hypotenuse, and here's the adjacent side, okay? So according to my measurements, which are just an approximation, but they're pretty good, I've got 51 on 93. Okay, 51 on 93. I'll leave that for now. Cos 35 is, according to the mnemonic, it's adjacent on the hypotenuse. It's this ratio. 78 on 93. 78 on 93. And then this one's going to be the last ratio, opposite on adjacent, 51 on 78. Good. Okay. Now, just by coincidence, all my numbers are divisible by 3. I totally did not then intend that. But anyway, you're going to get some other values, okay? Could someone give me an example of what they got for sine 35? What numbers did you get? Yes, Samir. 3 over 5.5. Okay. Someone else? Someone else? Someone else measured already? Anyone? Yep.
4 over 7.
4 over 7. Can I get one more? One more? Yep. 6 over 10.5. Okay, now, this is a bit hard to understand because it's all in fractions, right? I want to compare all of these numbers together. So, with your calculator there, where's mine? Let's convert all of these to decimal, okay? Because that'll be a bit easier to compare them. And what I've got was 51 divided by 93, which is 0.55. So that's 2 decimal places. Who was that? Sapir, what was yours? In decimal? You calculated it? Someone else want to help me out? And Jacob, you can work out yours as well. And Amy? What's your calculator, mate? Peter, can you work out one of them for me? Anyone?
What do you mean put in?
I got my one.
Yep.
Do I press SD and get it as a
Yeah, decimal, please.
0.57?
5.7. Okay.
Yep, I've got it later on.
Yep.
That's 0.545.
5.45. So I'm going to round that up, if that's okay. And who's got the last one? Yep. 5.7. Okay, so this is good. They're all slightly different, and that was because of what we mentioned before, that, you know, we're using a ruler. Like, I mean, for me, I just went to the nearest centimeter, okay? But we're all in the same ballpark, and you can do the same for these. You can get a decimal out, okay? Now, the next part, I think we're on to part D, says use a calculator to obtain these values, okay? So this is C. So now let's do this. 312, I think. Okay, so now your calculator, you can actually just go sine, it's right there in the middle, okay, 35. And you'll get a number out. You'll get sine equals 0.57. So we had Jacob and Amy's measurements were clearly better than mine and Sapir's, but there you go. We're all in the right ballpark, right? Sorry, that's really messy. Sine 35. Okay, so that's what it's actually, and there's more decimal places after that. But that's what it's actually equal to if we've drawn it really precisely. Okay, and of course you can repeat the process for these. Did I ask you to do something else? That was it.
So
Is that okay? Does that answer your question?
Is there no right or wrong answer?
For which part? You mean this part?
Yeah.
Yeah, I mean, they're all going to be roughly this, but because, you know, for example, I don't even have millimeters on my thing, so I can't measure.
Say when you're marking it, like, is it like 3?
Oh, sure, okay, right. So, I mean, this question you wouldn't really get in a test. The point of this question is to illustrate that what your calculator is giving you, right, it's not just random. It comes from this, if you could measure it precisely. Right, now we can't, but even with our inaccurate measurements, we can still illustrate. Look, 4 different triangles gave us all those measurements, but the ratios are pretty much all the same. They're pretty much all the same. The only differences are just accuracy. Okay. So I wouldn't worry about, oh, is this going to be right or wrong? This is what you're actually going to expect to use.